So we will now look at another alternative approach that we could have used here to value the call option. This approach might look very complicated at first, but this has a lot of applications, especially in more advanced courses that you might see. So it's worth thinking a bit here, since the approach is actually based on a similar logic to what we have been discussing here. Okay. So far, the binomial model valuation approach that we have been studying is arbitrage based in the sense that we figured out what's the value of this call option by creating a portfolio and replicating the payoff of this option with a combination of shares of stock plus borrowing that you have seen, right? So what we required in following this approach is basically just to kind of uh, figure out how to kind of combine the different assets in the right way, right? So we just needed to rely on the technology of replication, but nowhere did we use any risk preferences in the sense that we did not say that you have somebody who is risk averse, what's the risk premium, and so on, right? So what this suggests is that this valuation approach that we have done, right, and the pricing that we have derived on the based on this valuation model is that it is independent of risk aversion, right? And that actually suggests this approach, which is known as the risk neutral approach to valuing options. So let's take a look at that. So what we are going to do is we're going to consider a parallel economy to this original economy that we have, but the difference is that everybody in that economy is going to be risk neutral, right? Now, what's the significance of everybody being risk neutral? So that means that this economy is going to have people who only care about the expected payoffs, right? And they do not care about valuing or wanting risk premium in order to be compensated for risk, right? Now, what's the link of this risk neutral economy compared to the original economy that we had, where we were had the stock prices and we had discussed what's going to be the price of the option? Well, the answer is that in this risk neutral economy, you should still end up getting the same prices of the options, right? And why is that the case? Because remember, the option valuation that we had derived did not rely on risk preferences, right? So because it did not rely on risk preferences, if we change the risk preferences of the individuals that we are talking about, that should not actually have any effect on the price of this option, right? So therefore, we can look at a analogous risk neutral economy, right? So in this risk neutral economy, because they only care about expected returns and do not want risk premiums in order to be compensated for risks. So that means is that the investors basically value different items by discounting the expected payoff by the risk-free rate of interest, right? So this is exactly what, if you were a risk neutral person, you would have been doing. So what's the implication of this? So that means that any security, and in our case, the example of the security that we would be looking at is a call option. So that can basically be valued by calculating its expected cash flow and discounting it by the risk-free rate. Now, one thing that we have to be careful about is that when we are saying expected cash flow, we do not actually mean the expected cash flow that you have been studying in the uncertainty chapter, for instance, right? So this expectation is with respect to a probability measure. That's not the true probability by which the cash flow is changing, but it's the probability that would have prevailed in this risk neutral economy, right? Now, why is this the right formula for the price of the option? Because in this risk neutral economy, nobody cares about the risk. So once we have calculated the expected cash flow, where again, this expectation is something which is something that we have to be careful about, we just need to discount it by the risk-free rate in order to get this, right? So the trick is to get the expectation in the right way. So let's see how we would do that. So let's denote by P the probability that the stock price increases, right? Now, what is the property that this P must have? So this must have the property that because this is again a risk-free kind of like a situation, so it must have the property that the expected rate of increase of the stock price must be the same as the risk-free rate, right? So therefore, if we kind of like do the calculation, so this is, remember the stock was S, so it goes up to US or it goes down to DS. So this P must be such that the expected value of the stock price, which is PUS plus 1 minus PDS. So US is the stock price next period if it goes up, and DS is the price if it goes down. So that must be equal to 1 plus RF times S, right? Now, this is the crucial part, that this P that we are calculating, we are actually setting this P so that this relationship holds true, right? But this P need not be the actual P which tells us what's the probability that the stock price goes up, right? So this P is something that we are artificially creating, okay, so that this relationship holds true, right? That the rate of return of the stock price is such that it goes up at the risk-free rate. Why must this be the true case? Because here it must be the case that it has to go up by the risk-free rate, because remember, we have only risk-neutral investors, and therefore all of the assets in this economy should go up by the same price, right? That's the idea. Okay, so we can actually solve for P based on all this. So you can cancel out the S's, right? And so therefore you end up getting that P is equal to 1 plus RF minus T divided by U minus T. So again, this P is the risk neutral probability, okay? Because this is the probability that prevails in the risk neutral economy so as to equate the rates of return, right? And again, very importantly, this is not the same as the true or objective probability by which the stock goes up, right? This is something that we have created in order to use this in this economy. Okay, so let's look at an example. So this is remember the first example that we had seen when we were looking at option price valuation in the binomial formula, right? So you had got initially the stock price as 100, then it can go up by 120. So you would be here 1.2. Remember, U is 0 is 120, so therefore U is 1.2, or it can go down to 90, so therefore D was, remember, 0.9, right? Then you had the strike price was 110, the option was expiring in 1 year, and the safe rate of interest was 10%, right? So now, if you use this formula to calculate the risk neutral probability, so you have 1 plus 10% of 0.1 minus 0.9 divided by 1.2 minus 0.9, right? Based on all this information. And so you end up getting P equal to 2/3, right? Again, very important. This is not actually anything related to what was the probability that the stock price went up to 120 from 100. This is just the risk neutral probability that we have calculated on the basis of this imaginary risk neutral economy, right? Okay. Now, what's the advantage of calculating this P? Well, this is the probability measure that we are going to be using in calculating this discounted cash flow formula's numerator, which was the expected cash flow. So when we are calculating this expected cash flow, this is the P that we are going to be using. So 2/3, and the other one will be 1/3, right? So if it goes up, so this is 2/3. And once it goes up, the cash flow from this call option is going to be 10, right? Because you have got 120 and strike price is 110. So therefore, the cash flow from the call option is 10. And if it goes down to 110, which here would correspond to a risk neutral probability of 1/3, in that case, the cash flow from the call option is going to be 0, right? 90 minus 110. So in that case, you would not exercise the call option, and so therefore the cash flow is 0, right? And you're going to discount that by the risk-free rate. So this is 10%. So you've got 1.1 in the denominator. And if you do the calculation, you end up getting 6.06 as before, right? So this is an alternative way in which you could have derived it using first calculating this risk neutral probability, and then using the risk neutral probability as an input in calculating the expected cash flow, and then discounting it by the risk-free rate. Okay, so several things to note that, again, very important to know, this is not the true discounted value. Why is it not the true discounted value? Because of two reasons, right? So one, remember, in the discounted value, what you should have had is the expected cash flow, right? But then that expected cash flow, when we derived it, for example, in week 5, we had used the actual probability with which the stock went up or down, right? Here, instead, we are calculating the expected cash flow using these risk neutral probabilities, right? So therefore, that is one important distinction, that when we calculate this expected cash flow in this risk neutral world, in order to get this risk neutral probabilities and therefore the correct formulas, we are using the risk neutral probability and not the actual probability. The second thing to note is that even though you have got this risk involved, right? So the cash flow is going to be 10 or 0. So therefore there is risk, but we are still using the this risk-free rate to do the discounting, right? And why can we do it? Because this is the risk neutral world in which we are dealing with, right? So again, denominator is not the proper discount rate for option cash flow since one is not accounting for the risk. So in some sense, we are making a mirror in the numerator and making an error in the denominator, and these two errors cancel out, right? And this is not a coincidence, right? So the reason why these two errors cancel out is because exactly that we had that result that in the no arbitrage approach that we had discussed, risk preferences do not affect the option value. So we can make this sort of transformations, right? And therefore, the value that one has just computed for this risk neutral economy, so the value of the option that one has calculated, that's going to be the same as the value of the option that one could have calculated using these other methods that we have seen in the original economy, right? So you can use either of the approach. It's just that you have to be careful in thinking about what's the risk neutral probability and so on, and get the value of the option in this alternative way as well. And this is actually a much more general approach. We are not going to be seeing the true power of this. But if you take more advanced courses in, for example, investment or asset pricing, you will see that this approach keeps on coming up in different contexts. You might hear something called Aeronautics securities and so on. And this is the most fundamental tool when it comes to thinking about those different advanced approaches.